Welcome back, everyone. We have a block of lightning talks, starting out with Iulian talking about Bazel observability and remote services in a multi-build tool organization.
Oops, sorry. I don't know what I do.
Sorry, yeah.
Okay, can you guys hear me? Hello. So my name is, can I just click on slideshow maybe, or to make it a bit?
Yeah, you're in.
I think that's it.
Then you don't see the speaker notes.
Oh, sorry.
So we fix that for you. Then start talking.
Yeah. All right. So sorry for the hiccup. My name is Iulian Dragos. Perhaps surprisingly, as you see on the slide, I work at Gradle. So by the end of this talk, I hope it's going to be a bit less surprising because I'm here to talk about the Velocity, which is our enterprise product and platform for build observability and remote services. And the interesting characteristic of this product is that it supports several build tools, not just Bazel, and of course, not just Gradle. One small detail is that until about a month ago, the product was called Gradle Enterprise. So you might still spot the old name in some of my screenshots, but it's really the same thing as the Velocity. So we support 4 build tools: Bazel, Gradle, Maven, and Sbt. Sbt, if you haven't done Scala, is the build tool that is, let's say, that's the Scala build tool. And this product started more than 7 years ago, and it evolved into a platform for observability and build acceleration, growing out of the pain and difficulty of Gradle users of understanding and optimizing their builds. It's already deployed at many customers, small and large, from teams of 20, 30 people to 1,000 people like Airbnb or Netflix. And it works well with monorepos, which I think are very common in the Bazel world, but also companies that use hundreds of repos, and it pulls all the data from all the repositories and all the build tools into one single central, let's say, data analytics platform. So you can see your build trends and dashboards across all the build tools, not just one. Of course, you can also filter them if you want. So what does it do? Let's look first at observability, and we have 2 screenshots. On the left, it's a build scan, which is task-level analytics of a single build execution. So this is the most detailed, fine granular view you can have. Data is organized in several sections to try to make it easier to discover what happened. It's really like an X-ray of your build. You can have sections about dependencies, perhaps tests, the console output, a timeline view, of course, and so on. Then, if you take a high-level view, we have dashboards, which are a little bit like build scans integrated over time. So you have data collected over thousands or tens of thousands of builds, and you can uncover trends, or you can do analytics such as see how the build times are going, how flaky are the tests, are they flaky 10% of the times, what are the flakiest tests I have across all my repositories, and so on. So now that we had a high-level look at observability, when I said it's a platform for observability and acceleration, we have a couple of things that make your build faster. The first one is the remote cache service, which it's table stakes for Bazel, so I won't say too much about it, except that our implementation can serve the other build tools as well. So there's just one cache service that you can deploy, and it would serve cached entries for Gradle, Maven, and Bazel. Next, we have a thing called test distribution, which you can think about as a simplified or a special case version of remote execution, where we just distribute or scale out test execution, not the build part. And because in our data, up to 80% of the execution time in a build is due to tests, this is a sweet spot and somewhat easier to implement than full remote execution. If we move one step further, another feature that we're offering is called predictive test selection. And the idea here is to use all the data that I showed across many, many runs to build a predictive model based on what changes caused what tests to fail, and then select a subset of all your tests that would normally be invalidated by your build tool, and run only those to speed up and shorten the feedback loop on, let's say, pull requests. Of course, it's probably not going to be 100% accurate, so we recommend that you run the full test suite hourly or daily, nightly. But it does speed up a lot the feedback cycle on a pull request. So this is another acceleration technique we're using. And then Bazel remote execution, we don't have it yet. I know it's a hot topic, and we're working on it, but we're not there yet. So now let's look at the velocity for Bazel specifically. I think there are no surprises there. It uses the standard build event protocol. It's just a couple of options you would need to set up in your Bazel RC to be able to push the events to our server, and then you will be able to observe your build scans. This is one build scan. I think in this case, I was building the IntelliJ Bazel plugin. And then the first page is a summary. So I can't use the laser pointer, but at the top you see some user-defined tags, and then sort of the highlights of your build. I think maybe interestingly, we see that we ran 788 tests, but 127 test classes failed. How long they took each one of those. We can see the longest running executions, actions, and then we can link from all of these. And almost everything you see on this page or on any other section is a shareable link, so you can send it to your coworkers and say, look at this particular dependency, why is it in there, and so on. So if I were to click on one of the sections, for example, the timeline, I would see what you'd expect to see, a lot of build actions in different ways. And if I click on those, I'd get more details about it, but I don't have time. I mean, yeah, it's only 10 minutes. But if I went to the tests tab, I think this is actually the more interesting part. Besides the output and the stack trace, we notice one link there which says view test history. And if we click that, we would go to the test dashboard. And here I can cross-reference my test run with previous runs of the same test. So in this case, I see it failing for the past 2 days. Perhaps it's a new test that was just added and it's failing constantly. But then I can dig deeper, or I can actually use custom values and tags to filter my search. So if you see here, I'm restricting my search to a single feature branch. And then I see that it's only failing there. And if I look here, I could see probably all of those are local builds on macOS. I could have probably noticed that from the stack trace as well, but it seems to be a problem with macOS. The way these custom values and tags are added are as build metadata. So in this case, I added them as a workspace status command to be sort of a bit easier to run on every time I build. We use a naming convention to extract those. So if it starts with scan tag, it's a tag. If it's scan value, then it's a key value pair. In this case, it's a branch. And it just attaches those to the build and lets me further filter builds and test executions. All right, so what about the build cache? Our build cache is based on gRPC, and it's self-hosted. Actually, most of the things I showed are self-hosted. We offer sometimes managed installations, but usually clients or customers prefer to run themselves and operate the velocity. It's Kubernetes friendly, and maybe one interesting detail is that it's multi-tenant. So we offer project-level access control. If you have several teams or organizations that should not share cache artifacts, neither read nor write to those, this can be configured per build, and users can use access keys to read and write from the cache. And the same for the UI and so on. That's all I have. So if you want to find out more, you can find more on gradle.com/thevelocity. And we're also hiring. Come talk to me about either of the two. And I think we might have time for a question or two, if there are any. Well, thank you.